My name is Sara Robinson. I'm a developer advocate on the Google Cloud Platform team. You can find me on Twitter at srobtweets. And I'm going to be joined later in the presentation by Nick Hasty from our customer Giphy, and my teammate Zach Akil, another developer advocate. So let's get started by talking about what is machine learning. So at a high level, machine learning involves teaching computers to recognize patterns in the same way that our brains do. So as humans, it's really easy for us to distinguish between a cat and a dog. But it's much more difficult to teach a computer to be able to do the same thing. But how do we actually get from input to prediction? This is going to depend on the type of problem you're solving. I like to think of it along a spectrum. So on the left-hand side, let's say you're solving a generic task, something that someone has already solved before. On the opposite side of the spectrum, maybe you're solving something very custom that's specific to your data set. Let's think of this more specifically in terms of image classification. So for example, let's say we have this image of a cat. So the input to our model is the pixels in the image, and we want our model to output the label that there's a cat in this image. So many of you know this is a pretty common machine learning task. There's lots of pre-trained models out there that exist that have been trained to identify a broad range of categories in images. So you don't need to start from scratch. You can utilize an existing model. But let's say we have the same image, and we want, this cat's name is Chloe, and we want our model to be able to identify Chloe apart from the other cats in our image library. And maybe we even want our model to be able to draw a bounding box around her in the image. So this is going to require us to provide our own training data so that our model is able to differentiate between the different cats in our image library. Let's think of this one other way in terms of natural language processing. So let's take, for example, this text from one of my tweets. Let's say I want to extract the parts of speech from the text. So I want my model to be able to tell me what words are verbs, nouns, and pronouns. This is a pretty common natural language processing task. So again, I don't need to start from scratch. I can utilize an existing pre-trained model to help me with that. But let's say I've got the same input, and I want my model to know that this is a tweet about programming, and more specifically, it's a tweet about Google Cloud. So for that to work, I'm going to need to give my model hundreds or thousands of tweets about each of these topics so that it's going to be able to generalize and extract those topics from new tweets that it hasn't seen before. So in this talk, I want to show you how easy it is to add machine learning to your application using many tools we have available on Google Cloud Platform. So starting on the left-hand side, products that are targeted more towards application developers, we have a set of machine learning APIs. So these APIs give you access to pre-trained models. You just need to write one REST API request, and you can access all of these pre-trained models that we've already trained for you. You don't need to provide any of your training data. So it requires no machine learning expertise to get started. On the other side of the spectrum, we have products that are targeted more towards data scientists and machine learning practitioners, people that have a little bit more ML experience. So for this, we have Cloud Machine Learning Engine, which is our managed platform for training and serving your own custom machine learning models. So until recently, you'll notice there was kind of a gap in the middle. This is why I'm super excited about AutoML, which you may have heard about in the keynote. So AutoML is a tool that lets you train your own custom machine learning models without writing model code. So it lets you get a little bit more custom than you would with the APIs, for example. So you provide your own training data currently available for images, text, and translation. So now that you know the three different product areas we're going to be covering, let's dive right in with machine learning as an API. So as I mentioned, we have 5 pre-trained APIs that give you access to pre-trained machine learning models to accomplish common ML tasks like analyzing images, analyzing scenes in a video, converting audio to text, analyzing that text a little further, and then finally translating that text into over 100 different languages. I'm going to focus on just 2 of the APIs, vision and natural language, to give you a taste of what the APIs can provide. So starting with vision, these are all the features of our Cloud Vision API. So at its core, the Vision API will answer the question, what is this a picture of? That's label detection. So for this image, it might return elephant, animal, etc. Web detection will go a step further, and it will look across the web for similar or identical images. And based on the content of those pages, it'll return tags back for you on what's in your picture. OCR stands for optical character recognition. So this can extract text from images, it can tell you where that text is, and it can even understand the language of that text. Skipping ahead to explicit content detection, this will tell you, is my image appropriate or not? This applies to pretty much any site that has user-generated content. So instead of having someone manually screen each image, you just make one API call that'll tell you, is this image appropriate or not? So this is what a Vision API request looks like. You'll notice here we're passing in the URL of an image in Google Cloud Storage. You can also pass in your base64 encoded image directly in your API request. And then in the features block, we just tell the API what types of detection we want to run. So it's just a REST API. You can call it in any language. I've chosen to include a Python example here. So we have many client libraries to help you access these APIs in your favorite languages. So here we're using the Google Cloud Vision module for Python. We're creating an image annotator client. And then we're running label detection and analyzing those responses. So I never like to get too far into a talk without a demo. So let's go to the demo. So to show you what's possible with the Vision API, this is the Vision API product page. And you can try out all of our APIs directly in the browser by uploading your own images. So here what I can do is I can upload an image. I'm going to choose this selfie that I took when I was seeing Hamilton a couple months ago. And we can see everything we get back from the Vision API. So face detection is able to tell where my face is in the image. It's also able to detect emotion. So it says joy is very likely. I was super excited to be seeing Hamilton, so that is accurate. It also identifies where different features are in my face. If we skip ahead to web detection, based on other pictures of the same theater, it's able to identify the exact theater where I'm standing, even though the lighting in the picture isn't great. My favorite part about this is what's returned from our text detection endpoint. So when I first uploaded this image, ran it through the Vision API, I didn't even see any text in the image. But you'll notice that the word playbill is here on my program book, and the API is able to identify that for us. And then skipping ahead here, we can look at the full JSON response right in the browser. So I encourage you all to try this out with your own images, see if the Vision API is right for you before you start writing any code. So that's the Vision API. We can go back to the slides, and I'll include a link to that demo at the end. So that was the Vision API. Moving right along into Cloud Natural Language. So the Natural Language API provides 4 different features. First, it lets you extract entities from text. And then it lets you detect sentiment. So it can tell you, is this text positive or negative? If you want to get a little bit more into the linguistic details of your text, you can use the Analyze Syntax endpoint. And then finally, the newest feature of this is the content classification. So you can classify your text into over 700 different categories. This is an example of calling the Natural Language API in Node.js. Again, it's just a REST API, so you can use it in any language you'd like. So here, we're calling the Analyze Sentiment endpoint, and then we're analyzing the sentiment of our text. So let's go into a demo of the Natural Language API. Again, I'm going to show the product page here. So right in the browser on the NL API product page, I can enter text directly in here. So I'm going to enter some new text. So this is a sentence from an article about the World Cup published just a couple weeks ago. And we will see what the NL API is able to identify. So we can see it extracts all of these entities from our text. So if the entity returns a Wikipedia page, it will link to that page in the response. So this is one of the players. It links to the Wikipedia page about him. This links to the Wikipedia page about the French national football team, which is why it's categorized as an organization type. And then we also get the sentiment for each entity, broken down by entity. So score is a value ranging from -1 to 1, telling us if this entity is overall positive or negative. So that's what we get through entity analysis. Sentiment will give us the overall aggregate sentiment of the entire document, along with the sentiment for each sentence. From the syntax response, we get some additional linguistic details about the text, which you can see here, parts of speech, the role of each word in the sentence. And then finally, the content classification endpoint is able to identify that this is an article about soccer with 80% confidence. It's pretty cool considering the words soccer, football, World Cup are not actually explicitly mentioned in the text. And you can also look in the documentation to see a full list of the content categories that are available from this method. So that was the Natural Language API demo. We can go back to slides. Next, I want to highlight one of our customers that's using both the vision and natural language APIs in production. And for that, I want to welcome to the stage Nick Hasty, who's the Director of R&D at Giphy. Welcome, Nick.
Thanks, Sarah. So, hi, my name is Nick Hasty. I'm Director of Research and Development for Giphy. Giphy is about a 5-year-old startup. We have about 100 employees, 75 in New York, about 25 in LA. So today I'm going to talk to you about how Giphy used the Google Cloud Vision APIs and the Google Cloud Natural Language APIs to get better metadata about our GIFs and to also increase our search experience. So the problems that we were facing about 2 years ago, we were accumulating so many images, so many GIFs, that the ways in which we annotated those GIFs just weren't cutting it anymore. We had an editorial team. They would add tags and labels to GIFs, but we were working in tens of millions of GIFs, and we were getting thousands more every day. It's just not the best use of our resources internally to have people slaving away all day, adding tags. At this point in time, there was a good amount of availability of machine learning resources for object detection in images. We evaluated a lot of different options, including open source ones, but those have their own problems, like you got to deploy, and you got to do all these other things, and maintain services, and these kinds of things. We found that the Google Cloud API was the best thing for us overall. Again, what we were trying to do is pretty simple. We had a bunch of images. We just wanted to figure out what was inside those images. For Giphy, knowing if a cat is in an image is actually a big business deal for us. So we wanted to pull those things out. At any startup, you don't want to reinvent the wheel, and you want to minimize risk. So for us, to not have to train our own custom thing and to just be able to hit an API with an HTTP request and get really good quality metadata about an image, huge. This makes a job that would historically or anytime be like a whole team to a single person. So let me show you some of the results we got for this. So these are A/B test results. On the left-hand side, you can see improvements in CTR for our search results pages across our owned and operated. So the bottom line, the dark blue line, is the control group, and the top line is the light blue is our experiment group. The experiment group, we added Google Web Entities into our search algorithm as a signal. Google Web Entities, for us, were really awesome because not only do they provide generic labels, since they understand the context in which a GIF is found on the internet, there's a lot of time proper names in there, so you might find celebrities, TV shows, those kinds of things, which is our bread and butter. When we did this A/B test, you could see an 0.86% relative increase in CTR, which is a really good metric for us and for any kind of CTR evaluation. And then also, the other byproduct of this was we were returning less empty searches. So on the right side, those are non-zero results. So we were returning, so as you can see, we had a higher percentage of searches that were not empty. So a person would search for something, they wouldn't get anything back. Reason being, we had more metadata about our GIFs, which increased our overall relevance. The other thing, too, is a lot of our long-tail searches, we noticed those got really much better because a lot of the stuff was in kind of metadata limbo. We didn't really have good metadata around it. Now that we did, those things started coming up, bubbling up in the algorithm. So as we scrolled down our pages and our search results, we were just seeing better stuff all around. These numbers may seem kind of small in terms of, under 1%, but Giphy serves about 5 billion GIFs a day to 300 daily active users. So any increase in this amount is substantial. Okay, here's another thing we did. Hopefully you can see this. We needed to come up with better ways to title our GIFs. We use the titles anytime we display GIFs on the website, on our mobile apps, and these other things. So the old way we did this before we used Google Natural Language Processing API was we would just get the most popular tag on a GIF, and then we would say, most popular tag GIF. Not always wrong, but not really good. So you can see in the upper left, there's a chipmunk on the bed. That was just bed GIF. elephant jumping rope, that was just an animal GIF. And a guy professing his love to a woman at the door was just a love GIF. So what we wanted to do to increase these titles, so we came up with a bunch of semantic structures like noun, verb, adjective, noun, verb, that we knew that would be the best titles for us. Then we took all our tags, or a subset of our tags rather, we sent them to the Google Natural Language Processing APIs. We figured out their parts of speech. The other cool thing is the Google Natural Language APIs return Wikipedia articles, and they return knowledge graph references, so we were able to cross-reference those resources to figure out when we had a tag that was like a proper noun or those kinds of things. So then we got that data, we applied it to the structures, we started producing titles for these images. You can see bottom left, yawn stretch GIF, elephant jump rope GIF, Valentine's Day hello GIF, way better. We were super stoked with all that. That's it for us. Real quick, again, thanks. My name is Nick Hasty. You can get me nick@giphy.com. And below that is a bit.ly URL that leads to a blog post article on the Google Cloud Machine Learning blog, where I go into more detail about all this. Thank you.
Thanks, Nick. Awesome to see about customers using these APIs in production. So a lot of times when I present on our APIs, the first question I always get is, what if I want to train these APIs on my own custom data? And for that, I'm super excited about our newest product in cloud machine learning, Cloud AutoML, which lets you train your own custom machine learning models for vision, natural language, and translation without requiring you to write any of the model code. So this is a diagram of how it works. You upload your training data, could be images for AutoML vision, documents, text, sentences for AutoML natural language, and then sentence translation pairs for using AutoML Translate. AutoML provides a UI for uploading your training data, making sure your data is labeled correctly. You just click a button to train it, and then you get access to a custom REST API to make predictions on that data. And AutoML handles scaling it for you. So if your model becomes a smash hit, you get hundreds of thousands of requests. AutoML will scale up, and then it'll also scale all the way back down to 0, so you only pay for what you use. So let's get started right with AutoML Vision. And to show you AutoML Vision, we're going to dive right into a demo. And for this demo, let's pretend that I am a meteorologist. And I want to predict weather trends and flight plans from images of clouds. So this begs the question, can we use the cloud to analyze clouds? The answer is yes. So as I was prepping this demo, I learned that there's many different types of clouds, and they all indicate different weather patterns. So my first thought was, let's try this out with the Vision API. So for us, it's easy to see that these are obviously two different types of clouds. But for the Vision API, it was trained on a broad range of different categories of images. We wouldn't really expect it to know the scientific names for these types of clouds. You can see that for both of them, it returns pretty much the same label. It's sky, clouds, blue, etc. So the answer was to build a custom model in AutoML Vision. And let's jump over to the demo to take a look at that. So this is the AutoML Vision UI. It takes me through every step of building, training my model. So here what we have is the Images tab. It shows me all of the images that I'm using to train my model. I can either create a CSV with the URLs of my images in Google Cloud Storage, and in the second column I would have the associated label, or I can upload my images directly in the UI right here. So you can see in this model, our model is going to recognize 5 different types of clouds, as we see here, and this is the number of photos that I have for each one. So once I've got all my data in AutoML Vision, the next step is to jump over here to the Train tab. So this is where I can train my model. I can look at some metrics. So when I click Train, I can choose how long I want to train it for, right there. And once my model's done training, I'll get an email, and then it's time to look at some metrics to see how my model performed. And what I want to highlight here is the confusion matrix. So it's called a confusion matrix. It's actually not that confusing. What we want to see here is a strong diagonal from the top left. So this tells us the percentage of images in our test set that our model was able to classify correctly. So when we uploaded all of our images to AutoML Vision, it automatically split our images for us into training and testing. So when we're building any sort of machine learning model, we want to take the majority of our data and use it to train the model. But then when we test the model to see how it performed, we want to use data that it's never seen before. So this is evaluating on the test data. So we can see that it identified 92% of my cumulus clouds correctly, did pretty good for most of them, but for this one it looked like there were some issues. So for altostratus it only got 58% of those correct. Turns out it mislabeled a lot of them as cirrus clouds, and I can click here to see where my model got confused. So these were images it predicted correctly. These are images that were confusing. So this is where I can see maybe these images were labeled incorrectly, maybe they're confusing images that I should just delete from my data set. This UI helps you go in and see where you need to improve your training data. So that's the Evaluate tab. And the most fun part of this process is generating predictions once you've got a trained model. There's a couple ways to do this. I'm going to show you how to do it in the UI. So for this, we're going to upload images of 2 different types of clouds, and we're going to see what our model predicts. And there we go. So this is a cumulonimbus cloud. It's 96% confident that it predicted that one correctly. This is a mean type of cloud. You probably wouldn't want to see it if you were on a plane. This one is a cirrus cloud. It got 96% confidence. So you can try out your predictions in the UI. It's a great way to see how your model works right after it's been trained. But chances are you probably want to build an application that's going to make prediction requests to your trained model. So you get access to this custom API endpoint. Only you have access to this, or anyone that you share your project with. And let's say I decide to add a bunch more images to improve the accuracy of my model. I train a new version. All I need to do, or all the application developer needs to do, is change this model ID in the API request. So that is AutoML Vision. We can go back to the slides. So we announced AutoML Vision earlier this year, and some companies that have been participating in the alpha, first is Disney. Disney built a model to identify specific Disney characters, product categories, and colors that were specific to them. And they use that to improve the accuracy of their search results. Urban Outfitters is a clothing company. They built a similar model to identify characteristics in clothing, so types of patterns in clothing, types of neckline styles, things like that. They're using it to automatically tag products and improve their recommendations and search results. So those are some examples of companies using AutoML Vision in production. But vision is just one domain of machine learning. So what about other types of data, like text? That's where AutoML natural language comes into play. So I wanted to start out by talking about a couple potential use cases of AutoML natural language, why you might want a custom text classifier. So these are just a couple examples that I thought of. The first was, let's say you've got some data like a Stack Overflow question, and you want your model to automatically tag that question with an associated programming language. Or maybe you want to build a model that takes a news headline, is able to predict where that headline came from. I actually built a model to do this on AutoML natural language, and the results were pretty impressive. One other example is, let's say that you want to, you've got doctor's notes about a patient, and maybe you want to predict the possible conditions that would be associated with those symptoms. To show you how this works, I'm going to use a demo that you may have seen in the keynote with a data set from Donors Choose. So I found this data set on Kaggle. Kaggle is a data science platform that's part of Google. If you haven't heard of it, I definitely recommend checking it out. They've got a lot of great data sets on there. So this data set includes data from Donors Choose, and what they do is they match teachers with donors. So teachers that are looking for resources for their classroom will create need requests. They have volunteers manually categorizing those requests, and then they use those categories to route the requests to relevant donors who are interested in donating to the project. So they posted this data set to Kaggle to see if the community of data scientists and machine learning experts could build them an automated solution. So I thought I would try it out with AutoML natural language. So let's go to the demo. So as you'll see, the UI for AutoML natural language looks very similar to the UI for AutoML Vision. So here we have all of the text inputs to our model and their associated categories. These are all the possible categories in our data set. So we can see all of the categories here, and the train tab looks the same as AutoML Vision. We can take a look at the confusion matrix to evaluate the accuracy of how our model performed. You can see it did pretty well. We got, again, a strong diagonal down the top left, indicating that it categorized most of the text items from our test set correctly. So what we want to do next is run a prediction on some new text that hasn't been categorized yet. So we'll head over here to the Predict tab. And I'm going to take the following need request. Let me zoom in so you can all see that. It says, my students need aquarium lighting for our environmental clownfish aquaculture project. So this should be classified as lab equipment. And let's see if our model is able to identify it. So there we go. We can see our model identify this as lab equipment with 98% confidence, which is pretty cool considering it's not totally obvious from the text itself that this is the category that should be assigned. So again, similar to AutoML Vision, we get a custom REST API that we can use to make predictions on our trained natural language model. So we can go back to the slides. We go back to the slides. There we go. So next, I'm moving right along to AutoML Translate. Before I dive into AutoML Translate, I want to talk about why domain-specific translation is important. Because oftentimes, using our Cloud Translation API works great for many use cases. But there are certain situations where you do need domain-specific translation. Maybe you have a lot of industry-specific jargon that you need to translate. So I'm going to use this error message as an example. So the message says, device driver software was not successfully installed. So let's say I wanted to summarize this, focusing here on the word driver. Let's say I summarize this to say, the driver is not working, and now I want to translate that. So taken out of context of the error message, this actually might apply to a number of things. So the sentence is, the driver is not working. It could be referring to a broken golf club. My driver club is broken. It could also be referring to maybe a taxi driver is on strike. They're not working, so the driver is not working. Or it could apply to the software use case that we saw in the previous slide. So this is an example of why you might need a domain-specific translation model. To show you a demo, I'm going to use a dataset provided by one of our customers. Their name is WeLocalize. WeLocalize is one of the largest localization providers in the US, and they help their customers, which span many different industries, localize their content for global audiences. And so we're going to highlight datasets provided by two of their customers that they have experimented with AutoML Translate for. So those are OpenTable and Blackboard. So WeLocalize has a lot of localization expertise because when you build an AutoML Translate model, you need to provide it with thousands of sentence pairs translating from a source to a target language. So they have a team of experts that helps gather that training data and analyze the quality of the resulting model. So what OpenTable did, they've been experimenting with AutoML Translate during the alpha. They built a model that translates from English to German to translate restaurant reviews, descriptions, and UI elements on the site. For those of you that aren't familiar with Blackboard, it's an e-learning platform. It helps teachers post homework in their courses, let students engage in discussion and look up their grades, things like that. So they built a model to translate from English to Spanish, to translate user guides and UI elements on their site. So notice that both of these examples translate from English into a non-English language. To show you a demo, I've actually reversed the sentence pairs so that they translate into English so that you can see the benefits you get from using the custom model. The accuracy of the reverse sentence pairs is going to be pretty similar to the original models that they built. So if we could go to the demo. I'm going to show you a demo for both OpenTable and Blackboard. They have different data sets, obviously. So this is what the training data looks like in AutoML Translate. So here we have the German to English sentence pairs. This is the OpenTable example. So they're translating UI elements, restaurant reviews, and descriptions on their site. So when we go over here to the Train tab, you'll see what's called a blue score. And this is a score that's used by neural machine translation experts to evaluate the accuracy of a trained model. So what you want to see here is you want to see a higher blue score than the base model. This is what the translation API would provide on the same data. So here we got a 20-point improvement, and what we want to do here is generate a prediction on some new text. So I'm going to enter a restaurant review in German, and what we'll see up here is what we get from our custom model, and then we can compare that to what we get. This is the same exact response we'd get if we used Google Translate on the same sentence. So let's take a look. So the first sentence, service was nice and friendly. This is actually the same. So you don't always need a custom translation model, but there are certain use cases where it leads to a lot of improvements in accuracy. So here we see this was translated to drinks were upscale, which is a much better translation than the word lifted. And then right here it says we highly recommend, which again is a better translation than we can only recommend. So we get these small improvements, which do lead to a lot of accuracy improvements in the end. So that's the open table example. Looking at a different domain, let's take a look at the Blackboard model. So here I'm going to enter some text in Spanish, and we'll translate it, and we'll compare the results here. So here we notice right off the bat we get a better translation here of this word. So graders is obviously a term that's used across Blackboard's application. The baseline model would translate this to qualifiers, which doesn't really make sense in this use case. Retention center is a proper noun in their platform, which is translated more accurately by the custom model. And then here we have swiping versus scrolling, submission versus shipment. So submission is what they want to call submitting something in their platform. And then finally, submission listing, which is a better translation than ship list page. So you can see for any domain-specific translation use case, you do get a lot of quality improvements by building a custom model using your own training data for that. So we can go back to the slides. And then moving into the last part of the talk, what if you have a custom task that requires more control over your model type and its inputs? So some examples of this are, let's say you've already built your own model. You built a model in TensorFlow or scikit-learn, and you want to train that model. So maybe you want to train it on Google Cloud Platform, or maybe you want a scalable way to serve that model to handle lots and lots of prediction requests. Another example is, let's say you want to build a regression model. So that's a model that will output numerical values. So maybe you have a text input, and you want your model to assign some sort of rating to that text. Or maybe you have a model that has multiple inputs. So maybe it takes images and text as input, and then outputs some sort of prediction based on that. So these are all use cases where you want more control over your model. And for that, we have Cloud Machine Learning Engine, which is Google's managed platform for building, training, and serving custom models using your own data. So it's our fully managed platform for machine learning. It supports a couple of different frameworks. So it supports TensorFlow, Keras, and then most recently scikit-learn and XGBoost models for serving. So ML Engine is a way for you to train your models. So you can take advantage of using GPUs or TPUs, which stands for Tensor Processing Units, which will help you accelerate your machine learning workloads. So you can use it for training your models. You can also use it for serving your models. So once you've got a trained model, you can serve it on Cloud ML Engine, and then you get access to an easy-to-use API to make predictions on your trained model. One of the great things about ML Engine is that there's no lock-in. So let's say that I want to train my model on my own infrastructure, but then I want a way to serve it. I can upload it to ML Engine for serving, or vice versa. I could train it on ML Engine and then serve it somewhere else. Some companies that are using machine learning engine in production, Rolls-Royce has a TensorFlow model that they're using for the company's marine division. And they have an object detection model, which means that it returns the location of objects in an image, similar to the cat example that I showed earlier in the presentation. They're using that to identify and track the objects that a vessel can encounter at sea. Another example is Ocado. Ocado is the UK's largest grocery delivery service. As you can imagine, they get tons and tons of customer support emails on a daily basis. So they built a custom model to optimize how they handle those requests. So some requests don't require any response at all. Some requests are very urgent. So they're able to route requests appropriately using that custom model. And to show you a demo of ML Engine, I'm going to bring up my teammate Zach Akil to the stage. Welcome, Zach.
Thank you, Sarah. If we could switch back to the slides. Awesome. So I'm Zach Akil. I'm one of the developer advocates for Google Cloud Platform. And I'm really excited to show off how we can use ML Engine to deploy a custom model that we've built, and then how we can also integrate that into an actual app. So let's just jump right in and look at the problem that our app is going to solve. So this is a fun one. Given a movie description, can we predict the genre? So this is an example of a natural language problem. But as Sarah was saying, we could have easily have done an image-based problem or a numeric-based problem. We've just chosen this one because it's a bit of fun. But it'll be a bit special. So let's look at an example. So here's the description of, I believe it's one of the Oceans films. It's got crime in it. It's got action. So for our model, instead of predicting just a single genre, we're actually going to build it so that it predicts multiple genres. So this is an example of a multi-label classification problem. And ML Engine will handle this, like I said before, because it doesn't really mind what kind of problem we're trying to solve. It will just take the models that we built. So we've actually went away and we've built a couple of models to solve this problem. And if you want to have a go at solving a kind of movie-related problem, we've actually used this data set from Kaggle. It's a really, really good one. It's got like over 40,000 movies, and we were picking genres, and they've got loads of other features that we didn't even use. So really recommend using that data set. For the actual app structure that we built, we aim to build an app that's as simple as possible, but one that's also completely scalable. So we built a front end that's just static HTML. You'll see in a little bit, it's a really simple text box with a button that you just click. And we've actually just thrown that up onto the cloud storage. So cloud storage has a really cool feature where you can just throw up an HTML file, click a button to make a public link, and it will create a public URL that anyone can just go to, and it will render it as a web page. So we've just used that to host our front end. And obviously, the back end is going to be CloudML Engine. That's going to do the heavy lifting of actually hosting our deployed models. And more specifically, the models that we've built have been a combination of scikit-learn and TensorFlow. So you're probably already a bit familiar with TensorFlow. It's Google's deep learning framework. But is anyone in the room familiar with scikit-learn? Got any scikit-learn? OK, got like a handful. So scikit-learn is actually a really comprehensive machine learning library. But it kind of specializes in the parts of machine learning that aren't deep learning. So it has a lot of algorithms for clustering, for decision trees. And we're just going to show you how you can combine a couple of models and why that can be advantageous when you're trying to build machine learning algorithms. So we've got our back end, and we've got our front end. How we get predictions from our front end to our back end, we can send requests directly from JavaScript front ends to ML Engine. The one restriction in that is that all requests have to be authenticated. So we would have to build into our front end a way for our user to log in with their Google credentials and approve them to our own model. So that is actually a really good solution if you want to restrict the users of your model to be specific, so from a certain user group. But for our one, we want it to be as simple as possible. So we want users to be able to just go in and, without having to log in, get predictions. So that's where we have a cloud function. So we've built a really simple cloud function. All it does is it takes whatever prediction we're going to make. So it's going to take the description of the movie, and it's going to just slap on project credentials and send it off to CloudML Engine. So it's not changing any data. And a way you can think about this is it's providing an authentication sugar glazing on a prediction request donut. So it's not actually changing any data. It's just taking the request we're going to make, putting it on credentials. And Cloud Functions actually come with default credentials for your project. So they're really useful for doing this sort of thing. So let's actually stop talking about it and just show it. So we can switch over to the demo. So here is the CloudML Engine dashboard. So we can see our model here. And we can actually look at our app, which is here. So as I said, it was a very simple app. So it's just got a movie description and a button. So let's throw in a movie description here. So we've got this one. This is one of the Star Wars films. Does anyone have any predictions for what genre it's going to be? Just shout them out. OK, we've got sci-fi, we've got action. OK, let's see. So it's going to send a request off to our cloud function. That's going to go off to ML Engine, and it's going to come back with the genres. So you can see here it's predicted action, science fiction, thriller. Star Wars a thriller? Maybe, I don't know. So we're making predictions. That's the front end. Let's look back at the back end. So we can go back to CloudML Engine. So you can see we've got our model. It shows the default version, so keep note of that, because we'll come back to that later. So default version is version 1. We can look at our model and see that we actually have two versions of our model. We have version 1 and version 2. So when I was talking about how we built a model with scikit-learn and a model with TensorFlow, version 1 is our scikit-learn model, and version 2 is our TensorFlow model. So we can go back to our app, and we can get a prediction from our TensorFlow model. So I've just built in a little UI here, and boom. So that's getting predictions from a scikit-learn model alongside getting predictions from a TensorFlow model. And you can see here we've got some numbers. So the TensorFlow model, rather than it returning just the flags of which genre it is, it actually also returns probabilities. So we've just displayed those as well. And when we're making requests, although I've showed it with some radio buttons, all I would do is I would specify the model name. So in this case, we have a model named movies, and get prediction. And that's going to go off to our default model. So that's where the scikit-learn model. So that's why we've got the same tags as our scikit-learn model, because version 1 was our default model. So if we want to be more specific, we could say get from versions v1. And that's also going to go from our scikit-learn model. And then version 2 is our TensorFlow model. So it goes to show you how easy it is to just switch between versions of a model when you're making predictions on the application side. So that's version 1, that's version 2. Let's look at version 3. And oops, we don't have version 3. So let's actually go create version 3. So over in our dashboard here, we can go into the Cloud Shell. It's going to boot up a little mini instance for us to interact with the cloud. And when it's up, we'll be able to use the Google Cloud API to build all our models. So here's the dashboard. Here's the shell. We can use gcloud, and it's just ML engine. And for example, we can just list the models that we have. Hopefully, I've spelled everything. And it should show one model called movies. Makes sense? Now let's create a new version of that model. So if we go over to our cloud storage, I've actually created a really simple decision tree model in sklearn. And it's just sitting here in our cloud storage. So I'll run the command. I've cheated a bit here, so I've copy and pasted. I've made it before, but I'll talk through what it does. So we'll run it. And what we're doing, we're calling ML engine. We're saying, OK, you're going to create a new version. We're going to call it version 3. So our previous versions were called version 1, version 2. We could have called it version 3, but might as well mess with the application engineers that are going to build this and make inconsistent naming conventions. So we've called it 3. We've said, OK, it's going to be a new version for our model called movies. The framework is going to be scikit-learn. Makes sense. The runtime version is 1.5. And that is the runtime version of ML Engine that we're going to use. And the reason why we've chosen 1.5 is because that's the one that supports Python 3 models that we've built. So our scikit-learn model, when we were building it using Python, and it was in a version of Python 3. And so we tell it, OK, use runtime version 1.5, because that supports version 3. And then we've specified use Python 3. And then we've just told it where the model is actually stored. So we stored it in that bucket that I showed you before. In fact, you can see it here. And it's uploading now. So what's really exciting about why you can upload a model with just one command goes back to the sort of best practice with machine learning at the moment. And that is this kind of iterative leapfrogging idea when you're building models. So the idea is that you build a really, really simple model to begin with, even if it's underperforming, and then stop, put that to the side, and then build a second model to try to beat that model. And you sort of leapfrog with your models. So this is great. This is a great idea, except before you just build a model and put it off to the side. But now, because deploying is just one command, you're able to build a model and deploy the model. And what's really useful about this is that for application developers, they can immediately start building the application with the first model. And then whenever you upload more complicated, more advanced models, they don't need to change their application. So this is actually exactly how we built this demo. So I'm more comfortable with scikit-learn, so I started building a scikit-learn model. And then I threw it up on the ML engine. And whilst I was doing that, Sara was actually building a TensorFlow model. And so when I threw it up on ML engine, my scikit-learn model, I went off and I built the front end that you saw. And after the front end was done, and Sara finished the TensorFlow model, she just threw it up onto ML engine, and I didn't need to change my front end at all. I was able to immediately just get predictions from it. I didn't need to worry about installing dependencies. And if you've tried to embed machine learning algorithms directly into your application, you know how much of a pain this can be. So that's what's really exciting about ML engine. OK, so our model's uploaded. We'll go back to our app. We can see, OK, we're still getting predictions from version 1. Sending off to Cloud ML Engine, and it's going to come back. Cool. Version 2, awesome. Let's go back here. Let's try version 3. It's going to fail because we didn't call it version 3. We called it version 3. And then, and you can see it's a really simple decision tree, so it doesn't perform quite as well. But just to wrap up with this, let's create our own movie. So I'll say, let's see, the tale of a rogue engineer trying to deploy their model. Any guesses for the genre? OK, there's a few there. Let's see, scikit-learn model. See how that gets. Comedy. I guess it's a funny one. Let's see, TensorFlow. Actually, science fiction. That's pretty good. OK, let's try to influence this. So imagine we're a production company. We actually want to make a romance. So how would we call it? We would say, all that, blah, 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 blah. Who falls in love? Who falls in love? Let's see if any of our models pick up on it. OK, that one doesn't. Scikit-learn. Hey, we now have a romance. OK, so we can switch back to the slides. I hope that's shown you some of the power that ML Engine can bring when you're developing your custom machine learning models, and especially how it can sort of bring together your data scientists, machine engineers, with your application engineers in a nice harmony. With that, I will hand you back over to Sarah, and enjoy the rest of the conference.
Thanks, Zach. That was an awesome demo. Back to the slides. So we covered a ton of things in this presentation, so I just wanted to give you a quick summary to wrap up. So if you remember only 3 things from the presentation. 1, use a pre-trained API to accomplish common machine learning tasks like image analysis, natural language processing, or translation. You don't need any of your own training data to do that. You can get started right away, just one REST API request. Number 2, if you want to customize these APIs to your own specific training data, you can use AutoML, currently available for images, text, and translation. And then finally, as Zach just showed us, for custom tasks, you can build a model, train it on your own data, and train and serve it on Cloud Machine Learning Engine. So that's all we've got. Here's some resources if you want to learn more. I'll let folks take a photo of that slide for a moment. And thank you. Thanks, everyone, for coming.